Hi there. Welcome to our talk on unsupervised meta-domain adaptation for fashion retrieval. I'm Vivek Sharma, a postdoctoral researcher and a research scientist working at MIT, Harvard, and KIT. I'm presenting on behalf of my co-authors. The goal of this work is to learn domain-agnostic discriminative feature representations for cross-domain fashion retrieval. Given a query consumer image, our goal is to find its corresponding gallery shop image belonging to the same product ID. Cross-domain fashion item retrieval naturally arises when unconstrained consumer images are used to query for fashion items in a collection of high-quality photographs provided by retailers. Due to the challenging issue that in the target dataset we only have shop images without any label and have no access to any consumer image, in this work we tackle this challenging scenario by adapting a cross-domain retrieval model trained on a source consumer to shop dataset to a target consumer to shop setting using what we call a meta-domain adaptation method. We define a meta-domain as a high-level grouping of similar fashion items between the source and target datasets. Specifically, our aim is to learn domain-agnostic representations for the problem of consumer-to-shop fashion item retrieval for a target dataset by leveraging a consumer-to-shop retrieval model learned on a source dataset. This is a challenging new scenario, therefore required the introduction of a new concept to better understand it. As a first contribution, we would like to position it in the domain adaptation literature. The standard consumer to shop retrieval task only involves a target dataset. Standard domain adaptation could be considered to transfer a consumer to shop model from a source to a target set if those sets shared same product IDs. This is not the case for meta domain adaptation, where we have the additional challenge that no consumer image is available for the target set. This unsupervised domain adaptation scenario defined and is tackled in this paper. Generally, this cross-domain fashion retrieval is solved by using a joint embedding of shop and consumer images in the same space, and this shared representation is learned with a triplet loss. In order to generate such triplets, we rely on source and target assigned triplets. We assume the source and the target dataset share some similar fashion items. We cluster these shop images and leverage the clusters to automatically generate pseudo labels. Those are then used to associate consumer and shop images across datasets, which in turn allows to learn meta-domain invariant representation suitable for cross-domain retrieval in the target dataset. Our method works as follows. Our model is pre-trained on the source data set. Using Finch clustering algorithm, the target set is pseudo-labeled and are used to generate positives and negatives across datasets. Wherein for positive source consumer to shop pairs stay intact and the source target consumer to shop pairs are obtained by considering the global source items ID to the closest target item via clustering, and negatives are obtained via batch hard technique. The total loss is a combination of individual losses coming from consumer to shop, shop to shop, and consumer to consumer pairs. Then we either train MLP projection head with triplet loss, or we train the model end to end. And at the test time, we use this learned representation for the cross-domain retrieval task in the target set. We now compare our two models with existing supervised state-of-the-art methods. This includes models trained independently for each category and methods that use common model trained for all categories at once. Further, our best unsupervised model, UDMA-E2E, with ResNet 101 improves over the previous state-of-the-art supervised approach. With the comparable ResNet 50 architecture, we achieve better or on-par performance compared to these fully supervised methods, albeit having been trained in a much more challenging unsupervised meta-domain adaptation setting. Thank you.